This is section 3.4 on the angles of a triangle. First, we need to define what a triangle is, and this is the first time we've done that in this class. A triangle is the figure formed by three segments joining three non-collinear points. So really what you need first are three non-collinear points, and then make three segments that join those three non-collinear points. So you see a triangle drawn there. We know what a triangle looks like. Each of the 3 points is called a vertex, and the segments are called the sides of a triangle. So the vertices of this triangle, vertices is the plural of vertex, are A, B, and C. The sides are segment AB, segment BC, and segment AC. And the angles of this triangle, since every triangle has three vertices, every triangle will have three angles. We can call them angle A, angle B, angle C. Of course, we could also call them with three letters. Angle A would be the same as angle BAC. Angle B would be the same as angle ABC. And angle C would be the same as angle ACB. That's just the definition of a triangle, and we understand how that works. Now, triangles are classified often by the number of congruent sides they have. So we have three options. Either they have no congruent sides, they have two congruent sides, or they have three congruent sides. If they have no congruent sides, we call that triangle a scalene triangle. So scalene means no congruent sides. This triangle here is a scalene triangle. It has no sides congruent. They're all three different lengths. An isosceles triangle is a triangle that has two congruent sides, so one pair of congruent sides. This triangle is an isosceles triangle because this side and this side are congruent. And I tell that they're congruent because of those two marks that I just made on the diagram. So if we see those two marks on the segments of our triangle, on the sides of our triangle, then we know that those sides are congruent. They are equal in length. And then finally, an equilateral triangle is a triangle with three congruent sides. So I claim that this triangle is equilateral because that side, and that side are all congruent. They are all three the same length. So we can classify triangles by the number of congruent sides that they have. We can also classify them by the measures of their angles. If a triangle has all three angles acute, so all three angles less than 90 degrees, then that triangle is called an acute triangle. If a triangle has one obtuse angle, that triangle is called an obtuse triangle. And we'll see in a minute why it can't have more than one obtuse angle. It can only have at most one. If a triangle has one right angle, that triangle is called a right triangle. And again, we'll see in a minute why it can't have more than one right angle. And if a triangle has all three angles the same length, the same measure, then that triangle is called equiangular. So equiangular means all three angles are congruent. Equilateral, that we saw earlier, meant that all three sides were congruent. Alright, it's time for a theorem that a lot of you have been assuming, but that we haven't stated or proven yet. This theorem says that the sum of the measures of the angles of a triangle is 180 degrees. So if we add up all three of the angles that make up a triangle, we get exactly 180 degrees every time. We will prove that theorem in class, but that theorem relies upon parallel lines, and we'll see why when we prove it in class. And that's why it's in this chapter on parallel lines, because we need parallel lines in order to prove that the angles of a triangle add up to 180 degrees. Seems strange that we need parallel lines when there certainly aren't any parallel lines in a triangle, but we'll see why when we prove it in class. We know what a postulate is. A postulate is a statement that we assume to be true without proof. We know what a theorem is. A theorem is a statement that we prove using postulates or definitions or previously proved theorems. A corollary is a special kind of theorem. A corollary is a statement that can be proven easily by directly applying a theorem. So it follows very, very easily and very quickly from a theorem that we've already proven. Here are 4 corollaries to the theorem above, the theorem that said the 3 angles of a triangle always add up to 180 degrees. And these make sense. If 2 angles of a triangle are congruent to 2 angles of another triangle, then the third angles are congruent. If all 3 angles are adding up to 180 degrees, if 2 angles of one triangle are congruent to 2 angles of another triangle, those third angles have to be the same in order for each triangle to add up to 180. Another corollary is each angle of an equiangular triangle is 60 degrees. So remember, equiangular means all 3 angles are the same size. Well, if they're all the same size and together they add up to 180, they need to be 60, 60, and 60, because 60 plus 60 plus 60 is 180. In a triangle, there can be at most 1 right angle or obtuse angle. So that means you can't have 2 right angles in a triangle, you can't have 2 obtuse angles in a triangle, and you can't have a right angle and an obtuse angle in a triangle. And that has to do with the fact that the 3 angles have to add up to 180. We can't have 2 right angles because those 2 alone would add up to 180, and there would be nothing left for the third angle. We can't have an angle of measure 0 in a triangle. We can't have 2 obtuse angles because each one would have to be greater than 90, so when we add them together they're going to be greater than 180, and that's certainly not allowed, and it wouldn't leave any space for the third angle. And we can't have a right angle and an obtuse angle because the right angle is 90, the obtuse angle is bigger than 90, so they would add up to something bigger than 180. And finally, the acute angles of a right triangle are complementary. So if we have a right triangle, and let me draw this one out for you. If we have a right triangle, I mark that this is the right angle, so I know it's a right triangle. Then the acute angles of that triangle, which are the other 2 angles, have to be complementary. They have to add up to 90 because all 3 of these angles, we call that A, B, and C, angle A plus angle B plus angle C has to equal 180. Well, angle C is already 90, so angle A plus angle B plus 90 has to be 180. That means if we subtract 90 from both sides, that angle A plus angle B has to be 90, which is the definition of complementary angles, 2 angles that add up to 90 degrees. So that corollary follows directly from the fact that the sum of the measures of the angles of a triangle is 180 degrees. That's why we call it a corollary, because it easily follows from a proven theorem. So those are our 4 corollaries to the fact that the 3 angles of a triangle add up to 180. When one side of a triangle is extended, we call the angle that's formed an exterior angle. So in this picture, this angle is an exterior angle. I formed it by extending that left side of the triangle. I extended that left side up. It doesn't affect the triangle, but it makes an angle outside of the triangle. Since it's outside, we call it exterior. So that angle is called an exterior angle. Similarly, I have an exterior angle on this triangle on the right. I extended the bottom of the triangle to the left, and I have that angle there that's formed there. That's an exterior angle to the triangle. I could do that at every one of my vertices of the triangle. I've only done it on one vertice on each of these triangles here. Notice, though, what the measure of that exterior angle is. Since it and the interior angle next to it, so this angle and the angle that's 80, they together form a straight angle, so they have to add up to 180 degrees. That means the exterior angle has to be 100 degrees. It's not a coincidence that 100 is 70 plus 30, and the 70 and 30 are the two angles in the inside of the triangle that aren't 80. Those two angles are called remote interior angles. They're interior to the triangle, and they're remote because they're not related to the exterior angle. And then on the triangle on the right, the exterior angle I drew and the angle that's 115 have to be supplementary. So that means the exterior angle has to be 65. They have to add up to 180, so it has to be 65. And again, it's not a coincidence that 65 equals 40 plus 25, and 40 is the measure of that angle, and 25 is the measure of that angle. That is, in fact, the theorem. So notice the exterior angle equals the sum of the two remote interior angles. And that is the statement of this theorem. The exterior angle of a triangle equals the sum of the two remote interior angles of a triangle. If we draw an exterior angle by extending a side, the measure of that angle is what we get if we were to add up the two interior angles of the triangle that are not related to the exterior angle. Why that's true? Because all three angles of the inside of the triangle have to add up to 180, and this exterior angle is supplementary to that third angle on the inside. Okay, here are your immediate practice problems. For each of these diagrams, I want you to find the measure of angle A. So in the first diagram, you know one of the angles on the inside is 80 degrees. You have an exterior angle of the triangle that's 120 degrees. You need to find angle A, which is all the way on the right side. And number two, you have two triangles next to each other that share a common vertex, that vertex in the middle. The triangle that has angle A in it, you know one of the angles is 50, and in the other triangle, you have one of the angles marked as 50 as well. So you have to figure out how you can find angle A. And that is the end of section 3.4.